Okay, all right. So today we're starting coordinate geometry. That's the next topic that we're doing. Okay, Fatma, just to answer your question very quickly, you were saying in one of the questions in the non-calculator paper, you had 2 raised to power 10 to evaluate, right? And we're saying how many powers of 2 you should be able to calculate. Up to at least 2 raised to power 5, you should kind of remember because they're fairly straightforward. But beyond that, it's relatively easy to calculate because you're not going to do it like this 2 into 2 into 2 and so on. Instead of that, you can break it down into 2 parts. You can say, what's 2 raised to power 5? Let's evaluate that first. So 2 raised to power 2 is 4, 2 raised to power 3 is 8, 2 raised to power 4 is 16, 2 raised to power 5 is 32, right? So 8 is 2 cube, 16 is 2 raised to power 4, 32 is 2 raised to power 5. So 2 raised to power 5 is 32 already. 2 raised to power 10 can be written as 2 raised to power 5 plus 5, right? Which is the same thing as saying 2 raised to power 5 multiplied by 2 raised to power 5. So it's essentially 32 squared. Okay, 32 times 32. Now this is something that you can multiply now. 32 times 32, you can see what this turns out to be. Apply a multiplication process on this. Now this is a square that you're not required to memorize. Generally squares, you need to memorize up to 20. Beyond that, if there comes something like this, you can just multiply by writing it down like this. So you do normal multiplication. 2 times 2 is 4, 2 times 3 is 6. And then you have 3 times 2, which is 6, and 3 times 3, which is 9. And that gives you 4, 2, 1, 0, 1, 0, 2, 4. That will be 2 raised to power 10. So you don't keep multiplying by 2. Instead, you can find 2 raised to power 5 and then multiply that by 2 raised to power 5. That's one idea. Or once you know 2 raised to power 5, you can multiply 2 a few more times with that in your head if you think your mental math is good. So 32 times 2 is 64, then 128, then 256, then 512, and then 1024. Some people will be able to do this in their head, but if you find it difficult, you can break it down like this: 2 raised to power 5, 5 into 2 raised to power 5. Make sense? Okay. But 2 raised to power, until at least 2 raised to power 5, you should remember. Beyond that, you can do some quick multiplication either in your head or by writing it down. All right, so let's start with coordinate geometry. That's the topic that we're doing today. Now, what is coordinate geometry? First of all, it's basically about representing points, lines, curves on an XY plane like this. So you have an x-axis, the horizontal axis, you have the y-axis, the vertical axis. It's about representing points and lines on this axis and then doing some calculations based on that. So first of all, you need to be able to represent points on an XY plane like this. So for instance, if I have a point like this, point A, and it has coordinates 3 and 4, we can represent it on this diagram like this. Let's say this is origin, and then you have 1, 2, 3, 4 on the y-axis. On the x-axis, again, let's say we have 1, 2, 3, 4 on the left. On the right side of the left, we have -1, -2, -3, -4, and then we have -1, -2, -3, and so on. Now, you should be able to represent this point on this graph. What does it mean? It means the x coordinate is 3, the y coordinate is 4. So you go 3 units horizontally and then 4 units up. The point is going to be this point here. This is point A. Let's mark another point. Let's say we have a point B, and that point B, let's say, has coordinates -2 and let's say -1 and 2. Now, where is this point going to be? This will be on the left side, right? The x coordinate is negative, the y coordinate is positive, -1 and 2. And that point will be somewhere around here. Let's say this is point B. Okay, so you should be able to mark points like this on an XY plane. Now, using these points, there are a few calculations that you need to be able to do. For instance, you should be able to find distances, distance from distance between 2 points. You should be able to find midpoints of 2 points. You should be able to find equations of lines joining 2 points. So calculations like these, you should be able to do these calculations. Now, first of all, let's start with the distance formula, distance between 2 points. So let's say we're interested in finding the distance between these 2 points, A and B. So this distance, okay? Now, how do you find this distance? We have a formula for that, and that's called the distance formula. And it looks like this. Distance between 2 points, A and B, is given by x2 minus x1 whole squared plus y2 minus y1 whole squared. And then square root of that whole thing. Now, how are you going to use this formula? You have 2 points, A, which is 3, 4, and you have B, which is -1 and 2. You call any one of these set of points x1, y1, and then you call the other one x2, y2. So for instance, in this case, you can call this x1, y1, and the other one you can call x2, y2. Okay. Now, just input values in this formula, x2 minus x1. What do you get from that? -1 minus 3, right? -1 minus 3 whole squared plus y2, which is 2, minus y1, which is 4, and you have 2 minus 4 whole squared. Now you simplify this, and you have -4 whole squared plus -2 whole squared. Remember, whenever we take square of a number, it becomes positive. So we have 16 plus 4 inside the square root, and that simplifies to square root of 20. You can leave it like this if you want, or if you want to simplify this, this would become 4.47 in decimals to 3 significant figures. That's the distance between these 2 points. That's how we find distance between points. You need to remember this formula, x2 minus x1 whole squared plus y2 minus y1 whole squared, and then square root of that whole thing. This is the distance formula. Okay. Now the logic behind is basically Pythagoras. This formula comes from Pythagoras. How exactly? Basically, you can make a right angle triangle. If you have any 2 points, A and B, what you can do is you can make a right angle triangle like this, such that the length AB is the hypotenuse, the side AB is the hypotenuse of this triangle. Okay. And now, in this triangle, what's the base of the triangle? You see this x coordinate is 3. And on the left side, the x coordinate is -1. So you have one x coordinate 3, the other -1. What's the difference between 3 and -1? 3 minus -1, that becomes 3 plus 1, which is going to be 4. So this length is supposed to be 4, right? So essentially what you're doing is you're subtracting one x coordinate from the other x coordinate, 3 minus -1, and that becomes 4. Okay, that's the base. And then how do you find the height of the triangle? This side, this is 2, this is 4, right? So the difference between the y coordinates is going to give you this height of the triangle, the perpendicular. That will be 4 minus 2, 4 minus 2, right? And that gives you 2. So the base is 4 and the height is 2. And essentially what you have to do now is, if you have to find the hypotenuse, using Pythagoras, you can say hypotenuse square is base squared plus perpendicular squared. Base is 4, so that's 4 squared plus 2 squared, and then square root of that, and that gives you square root of 20. That's exactly what we're doing here in the distance formula. We are subtracting the x coordinates to find the base of the triangle. We're subtracting the y coordinates to find the height of the triangle. So we square them, add them, and then take square root, and that gives us that distance. Okay, so that's the logic behind it. Now, even if you understand the logic, eventually you need to memorize the formula. Okay, you should understand where it comes from, but then you need to memorize this formula as well. X2 minus x1 whole squared plus y2 minus y1 whole squared equals the distance. Square root of that equals distance. Okay, that's the distance formula. That's the first formula that you need to know in this topic. The distance for finding distance between 2 points. All right. Okay. Now this is the formula that you use to find distance between any 2 points: x2 minus x1 whole squared plus y2 minus y1 whole squared and square root of that. Okay. Now the second thing that you will have to do sometimes would be that you would have to find midpoint of 2 points. So let's say you have these 2 points, A and B, and what you're interested in is that you want to find the midpoint, the middle point of the line joining these 2 points. Okay. Now, how do you find that? Using the midpoint formula. And this is what it looks like: midpoint of AB. It's x1 plus x2 over 2 and y1 plus y2 over 2. So what we do is we add the x coordinates, divide the result by 2. We add the y coordinates, divide the result by 2. And from that we get the midpoint of these 2 points. Let's apply that here. We have these 2 points, A and B. Let's input values in this. Let's see what we get from that. 3 minus 1. x1 plus x2, that becomes 3 minus 1 divided by 2. y1 plus y2, that becomes 4 plus 2 divided by 2. Now simplify this. 2 over 2 is 1 and 6 over 2 is 3. This is the midpoint that we get from this. Okay, so that's how we find the midpoint of 2 points: x1 plus x2 over 2, y1 plus y2 over 2. Again, you need to remember this formula. This will give you this point in the middle. If we call this point M, this would have coordinates 1 and 3. And that's what we found there, 1 and 3. Okay. Now, where does this come from? Essentially, what we're doing is we're saying, since we're looking for the midpoint, this is the x coordinate of one point. This is the x coordinate of the other point. If you're looking for the midpoint, essentially, we're looking for the average of these 2 points, right? So we find the average of -1 and 3. How do you find average of anything? You add those two numbers, divide by 2. Similarly, the y coordinate as well. One is 2 and the other is 4. We find the average to get the y coordinate of the middle point. Okay, so that's where this formula comes from. We're essentially taking averages of the x coordinates and the y coordinates respectively. All right. Okay. Now that's the distance. That's the midpoint formula. That's the second formula that you need to know of. Then another thing that you need to know is how to find gradient of the line joining 2 points. Gradient of AB. Now, what's that? This is what the line looked like, the line that I have here. Let me draw this line here as well. A has coordinates -1 and 2, and B has that was B. B has coordinates -1 and 2, and A has coordinates 3 and 4. These are the 2 points that I have. Now, how do you find the gradient of these two of the line joining these 2 points? Gradient is defined like this. It's the change in y over the change in x. And the formula that we use for this is y2 minus y1 over x2 minus x1. So if we call any of these two sets of points x1 and y1, and we call the other x2, y2, then the gradient is defined as y2 minus y1 over x2 minus x1. Now, what exactly does it represent? It's the change in y over the change in x. Okay. Now, let's actually find the gradient for this particular line and then try to understand what that number really means. Okay, let's first find the gradient of this set of points. So let's apply this formula on this. Y2 minus y1, that will become 4 minus 2 divided by x2 minus x1. So that's 3 minus minus 1. Let's do that. 3 minus minus 1. What do we get from that? 2 over 3 plus 1, which is 4. And that evaluates to 1 over 2, or you can say 0.5. This is the gradient that we're getting for this line, the line AB. Gradient of the line joining the points A and B is 0.5. Okay, it's change in y over change in x. Now, what exactly does this number represent? What do you understand from the 0.5? What does it really mean? Basically, gradient is telling you, so formally we call it like this. We say this is the rate of change of the y-axis or the whatever the value is on the y-coordinate with respect to x. Now, what does that mean? Rate of change of y with respect to x. This basically means if you were to change x coordinate by 1 unit, let's say you had to go 1 unit to the right, how much would you change on the y-axis? Okay, so this 0.5 is telling you if you were to go 1 unit in the x direction, the change in the y direction would be 0.5. That's the interpretation of this number. So this 0.5 is telling you if x coordinate increases by 1 unit, the y coordinate would increase by 0.5 units. That's what the gradient of this line represents. Okay, that's the interpretation of this. That this line looks like this. Let me write that down as well. The gradient is telling you, the understanding of gradient is that it tells us the change in y if x increases by 1 unit. So what does 0.5 mean then? If x increases by 1 unit, y would change by 0.5. Okay, so y would increase by 0.5. If it was a negative gradient, that would mean that y is decreasing by that number. So for instance, for a particular line, if we were to get that the gradient is, so let's say we have a line and that line has a gradient of some negative value. Let me actually take a set of points. Let's say I have a point which is point P, and it has coordinates -1 and 5. And I have another point Q, and that has coordinates 3 and 1, or let's say 3 and -3. Okay, now what's the gradient of PQ? Let's find that out. We call any of these points x1, y1, and then we call the other one x2, y2. Let's say this is x1, y1, and this is x2, y2. What's the gradient formula? The gradient formula is y2 minus y1 over x2 minus x1. Let's apply that formula here. Y2 minus y1 over x2 minus x1. What do we get from this? -3 minus y1, which is 5, divided by x2, which is 3 minus x1, which is -1. And that simplifies to -8 divided by 3 plus 1, which is 4. And that simplifies to -2. So gradient in this case turns out to be -2. How do you understand this? This means that if x increases by 1 unit, if x increases by 1 unit, y decreases by 2 units. So that is why the line that we have joining these 2 points, that will be a downward sloping line. So if you go 1 unit to the right, y is going 2 units down. That means this is the line that we actually have. The line looks like this. It's a downward sloping line like this. Okay, that's the interpretation of gradient. That's the understanding that we have of gradient. Okay, so these are 3 formulas that we need to know. First of all, distance formula, x2 minus x1 whole squared plus y2 minus y1 whole squared, square root of that. The midpoint formula, x1 plus x2 over 2, y1 plus y2 over 2. And then this gradient formula, y2 minus y1 over x2 minus x1, and the understanding of gradient. This will really help later on in your A-levels and in your SAT math tests later on as well. Understanding what this gradient means. The interpretation of gradient is if x increases by 1 unit, how much does y change? Okay. All right. Now, there are different cases that you can have for gradient. You can have lines that have gradient that is positive. You can have lines that have gradient that is negative. You can have lines that have a gradient of 0. And sometimes you can have lines that have gradient that is undefined. Okay. Let's try to understand each of those cases now. First of all, when do you have positive gradient? When is the gradient positive? The gradient is positive when you have a line like this, that as you go from left to right, the graph is going up, right, in this direction. So from left to right, the graph is going in the upwards direction. That's how positive gradients lines look like. If you increase x, y also increases. Okay. What about negative gradient lines? Negative gradient lines look like this, that as you go from left to right, the graph is going downwards. Okay. And what that means is if you increase x, y actually goes down, y decreases. That is why the gradient is negative. So the rate of change of y with respect to x is negative in this case. Okay. These are 2 types of lines that you would see, positive gradient and negative gradient. Then sometimes you can have horizontal lines. So for instance, what if you have a line that looks like this, a horizontal line like this? What's the gradient of this line? Remember, gradient has another name as well. We also sometimes call it the slope of a line. Okay, you should be familiar with this other terminology as well. Gradient has another synonym as well, and it's called slope. Now think of it in terms of slope. So in the first case, there was some slope here of this line, right? It was a slanted line. In the second case as well, there's some slope of this line. Now think about this. It's a horizontal line. Does it have any slope? It does not really have any slope because it's a horizontal line. So this would have a slope of 0 or a gradient of 0. Why? Because it's just horizontal. Now you can think of it different ways. One way is, remember the interpretation of gradient. How many units does y change if x increases? Now, if you increase x in this case, y is not changing at all. There is no change in y, so we can say the gradient is 0, right? So you can think of it different ways. As a result, the gradient that you get from this is going to be equal to 0. So the gradient is 0. Okay. You can apply the formula as well. If you were to take any 2 random points on this line, for instance, let's say I have this point. Let's say it has coordinates 2 and 5. I take another point on the right side. Now its x coordinate might be different. It would be any other number. Let's say that is I don't know, 8. But since it's a horizontal line, the y coordinate of this point would also be the same. That would be 5. Y coordinate would not change because it's a horizontal line. And now if you were to apply the gradient formula, you would see what you get from that. Y2 minus y1, that will be 5 minus 5 divided by 8 minus 2, and that is 0 over 6. Now 0 over anything is 0, so the gradient turns out to be 0. And from that we understand horizontal lines have a gradient of 0. Okay, horizontal lines have a gradient of 0. Horizontal lines have a gradient of 0. So this was the positive gradient case, this was the negative gradient case, and this is where the gradient is 0 because it's a horizontal line. Now, what about vertical lines? What if you have a line that looks like this? You have a vertical line like this. Okay. What about the gradient of this line? Again, let's understand it from the definition of gradient. First of all, what was the definition of gradient? How much does y change if x increases by 1 unit? Now, that question even does not make sense here because we cannot really increase x coordinate at all. There's no change in x here. So we can't even ask that question, that how much does y change if x increases by 1 unit, because x is not increasing. X is not even increasing. Okay. So another way to think about this is, if you apply the gradient formula on this, how would that work? Let's take any 2 points on this line. So let's say I take 1 point here, and let's assume it has coordinates 1 and 6. I take another point on this line, let's say here. Now its y coordinate is going to be smaller because the point is below the other point. So let's say this y coordinate is 2. What about the x coordinate? The x coordinate will remain the same. That cannot change, right? Because it's a vertical line. Whatever was the x value here, that will be the same for both of these points. So the x coordinates will be the same. So this would also have an x coordinate of 1 in that case. Now, if you apply the gradient formula, the gradient turns out to be 6 minus 2 divided by 1 minus 1. And that gives you 4 over 0. What's 4 over 0? 4 over 0 is undefined. You cannot divide anything by 0. Division by 0 is not possible. So this is actually a case when the gradient is undefined. For vertical lines, the gradient is undefined. Okay? Because we end up getting a 0 in the denominator, and division by 0 is not possible. We cannot divide by 0. That is why it's undefined. Okay? And as I said before, x is not even changing here. So this interpretation of gradient that we looked at earlier, it tells us the change in y if x increases by 1 unit. X is not even increasing there. So the question does not make sense. That's why the gradient is undefined. Okay, so we've got 4 cases here. Top left, positive gradient. Top right, negative gradient. Bottom left, horizontal lines, you have a gradient of 0. And bottom right, vertical lines, in this case, the gradient is undefined. So undefined gradients are when you have vertical lines. Okay, now this is what you need to remember. What positive gradient lines look like, negative gradient lines look like, what horizontal line, what the gradient of 0. When would you get a gradient of 0? When lines are horizontal. And when would you get a gradient of undefined? That is when you have vertical lines. Okay. Now, just a brief pointer on this. Those of you who don't know why 4 over 0 is undefined, 0 over anything is 0. Okay. But when you have 0 in the denominator, this is undefined. Now, let's quickly understand again, for those of you who are interested, how does division work? let's say you have 12 over 4. What is that equal to? 12 over 4. That is equal to 3, right? 12 divided by 4 is equal to 3. Now, why is it 3? 12 over 4, why is that equal to 3? It's 3 because 12 over 4 is basically asking how many 4s can we add to get 12? Or what do we multiply 4 by to get 12 as the answer? What do you multiply 4 by to get 12 as the answer? We multiply 4 by 3, and that would give us 12 as the answer, right? Now, do the same thing with 0 in as the denominator. So if you were now doing 4 over 0, again, what are you asking yourself? What do you multiply 0 by to get 4? What number can you multiply 0 by such that the result is equal to 4? Now, that does not make sense. You cannot multiply 0 by anything such that the result would be 4. So no such number exists. That is why we say this is undefined, right? Because division by 0 is not possible. Okay? There's no number that you can multiply by 0 such that the answer is 4. So whenever you have 0 in the denominator, this is undefined. Okay? Now, this is something general that you need to keep in mind. Again, later on in A levels and beyond, you will see cases where you have 0 in the denominator, and where you would make sure that you avoid getting 0 in the denominator, because if that happens, you would end up getting something that's undefined. Okay, so you need to keep this in mind. You can never divide by 0. Division by 0 is not possible. Okay, all right. So we talked about all of these different gradients that are possible. Now, about gradients, there's another thing that you need to know about, and that is what happens when you have two parallel lines, when you have two perpendicular lines. What do their gradients look like? Let's start with parallel lines first of all. So let's say you have two lines that are parallel to each other. Now, what are parallel lines? Parallel lines are lines that have the same direction. Okay. So you have a line like this, and you have another line that is in the same direction. These two lines are parallel. Now, there's something that you need to know about the gradients of these lines. What does gradient represent? Gradient, in a way, is telling you the direction of the line, right? So these lines had positive gradient when we were going in the upward direction. When we were going in the downward direction, the gradient was negative. When the direction was horizontal, gradient was 0. When the direction was vertical, gradient was undefined. So gradient, in a way, tells you the direction of the line. Now, when you talk about parallel lines are lines that have the same direction, right? Let's say the gradient of this first line is m1 and the gradient of the second line is m2. Now, since parallel lines have same directions and gradient represents direction of a line in a way, parallel lines have equal gradients. So if two lines are parallel, one of them has gradient m1 and the other has gradient m2, the gradients will be equal to each other. So if you know one gradient, you would know that the other is also the same. Okay, so if you know that, for example, the first line has a gradient of 3, the other would also have a gradient of 3 in this case. Okay, so parallel lines have equal gradients. All right, okay. Let me just write that down here as well. Parallel lines have the same gradients. Okay, now what about perpendicular lines? What happens if you have lines that are perpendicular to each other? Now, what are perpendicular lines? Perpendicular lines are lines that make a 90 degrees with each other. Okay, so let's say I have a line like this. and I have another line like this. Now, if the angle is 90 degrees here, that means these lines are perpendicular. Okay. Now, what about perpendicular lines? In perpendicular lines, if the gradient of one of the lines is m1 and the gradient of the other line is m2, then the gradients are related in this way that we say m1 times m2 is equal to -1. So when lines are perpendicular, the product of their gradients is always equal to -1. Okay. Now, this is a relation that you need to keep in mind. You can also rearrange this in such a way that it becomes m1 equals -1 over m2, right? I can divide one of the gradients on the other side so that it becomes m1 equals -1 over m2. Now, what that means is if you know one gradient, for example, if you know m2, then what is the other going to be? The other is going to be negative reciprocal of the first. Okay. You will change the sign and take reciprocal to find the other gradient. Let me give you some examples. This is a quicker way of finding gradients rather than having to use this equation every time. If you know one of these gradients, you can write down the other directly like this. For instance, let's say we have a line that has gradient m1 and another that has gradient m2. And you know that one gradient is, let's say, 5. If the other line is perpendicular to it, what would be the gradient of that other line? Negative reciprocal of this. What does that mean? You change the sign. So this was positive, you make it negative, and you take reciprocal, so it becomes 1 over 5. So if one line has gradient 5, the other line would have gradient -1 over 5. Okay. And then let's look at another example. Let's say we had one line that has gradient -3. What about the other line? Change the sign, take reciprocal. So that becomes positive now. +1 over 3. Okay. Similarly, if one gradient was, let's say, 1 over 4, the other would be -4. Change the sign, take reciprocal. If one was, for instance, -3 over 5, what would be the other one? Take reciprocal and change the sign. So that becomes positive. And reciprocal of 3 over 5, what would that be? That will be 5 over 3. So if you know one gradient, you can find the other by just taking negative reciprocal of the first one. All right. Okay. Now, let me write that down here as well. Gradients of perpendicular lines are negative reciprocals of each other. Gradients of perpendicular lines are negative reciprocals of each other. All right. Parallel lines have equal gradients and perpendicular lines have gradients that are negative reciprocals of each other. Now, these are two important results that you need to keep in mind. Now, once we understand this, the most commonly asked problem in coordinate geometry would be where you would have to find equation of a line. Finding equation of a line. Let's move on to that now. Finding equation of a line. Now, in one of our previous classes, we understood how to solve equations simultaneously, right? Let me show that to you quickly. So we talked about how to solve equations like these. Solve this and this simultaneously. Now, where exactly do these equations come from? Now, we know how to solve them simultaneously, okay? But where exactly do these equations come from? 3x plus 4y equals 1, 5x minus 8y equals 9. What do they represent? How can you find equation of a line given some information? That is what we need to talk, that is what we want to talk about now. Now, straight lines look like this. They have the standard form. Y equals mx plus c. This is the standard form of a straight line equation. Y equals mx plus c. In this form, m represents the gradient of the line and c represents the y-intercept of the line. M is the gradient and c is the y-intercept. Okay, now gradient, we understand what that is, right? What's the y-intercept? Y-intercept is basically where the line cuts the y-axis. This means the point where a line cuts the y-axis. Or not just a line, it could be any graph, where a graph cuts the y-axis. That's the general meaning of y-intercept. So when you have a straight line, this is the y-axis, this is the x-axis. If the line looks like this, this point here is the y-intercept of the line. If we know the gradient of the line and the y-intercept of the line, we can write down the equation of the line using the standard form y equals mx plus c. Okay. For instance, let's say this line has an equation of y equals 2x plus 5. What exactly does that mean? That means that the gradient of this line is 2 and the y-intercept is 5. That means this point here on the y-axis is 5. Okay. And then what does this equation represent? Y equals 2x plus 5. This equation represents every single point on this line that we have drawn. Every single point in this line will satisfy this particular equation. So, for instance, if you have a point, a random point here, and it has coordinates, let's say negative 2. That might not work. Let's say it has coordinates negative 4 and negative 3. If this point lies on the line, it has to satisfy this equation. So you can check that y equals 2x plus 5. If you input the values of x and y in this, minus 3 equals 2 into minus 4 plus 5. On the right side, you have minus 3. On the left side, you have minus 3. It will always satisfy the equation of this line. And it's not just for this one point, it's true for every single point on the line. So y equals 2x plus 5 being the equation of this line means that every single point on this particular line, on this green line, will satisfy the equation of this line. Okay? That's what it means for this equation to correspond to this line. That every point that lies on the line will satisfy its equation. You can write that down here as well. Every single point that lies on the line satisfies the equation of the line. What does it mean to satisfy the equation of the line? It means when you input that point here, the left-hand side and the right-hand side, they will be equal to each other. Okay? So now the question is, how do you find such an equation? How do you find equation of a line that looks like this? How do you find that equation? Let's understand that process now. This is the standard form that we will be using, y equals mx plus c. Let's see how we can find the equation of a line given some information. We are done with these topics until now: arithmetic, algebra, basic algebra, quadratics, where we talked about quadratic equations and completing square form and simultaneous equation, how to solve simultaneous equations which are both linear. And now we're doing coordinate geometry, and most of the difficult topics are still to come. Okay. All right. So how do you find equation of a line? Let's say we have a problem like this, that we want to find the equation of a line that has gradient -2 and y-intercept 5, or let's say y-intercept 3. Okay, how do you write down the equation of this line? This is fairly straightforward because both the things that you need in this case are already given. Y equals mx plus c. What information do you need to be able to write down the equation? You need two things. You need the gradient and the y-intercept. In this particular example, both of those things are already given. So there's nothing that you really have to do in this. You have the value of m. You have the value of the y-intercept, that is 3. That's c. So the equation therefore becomes y equals -2x plus 3. That's the equation of this line. So this is fairly straightforward. You could just input values like this. What if you had something that was slightly more complicated? So for instance, instead of telling you the y-intercept, what if they told you about any other point on the line? So what if you had something like this? We had to find the equation of a line that has gradient, let's say 4, and it passes through a point which is -2 and 5. How do you find the gradient of this line? How do you find the equation of this line now? So now you don't have the y-intercept. The standard form looks like this. It's y equals mx plus c. That's the standard form for the equation of a line, right? Y equals mx plus c. What do you need to write down the equation of the line? You need the gradient and you need the y-intercept. These are the two things that you need for that. Now, do you have the gradient? Yes, you have the gradient. The gradient is 4. That's the value of m that we needed. What about the value of c? The y-intercept, that is not given, right? C is not known. Now, what do you do in this case? How do you find the equation of the line? What you can do is, first of all, you can put that value of m inside this so that the equation becomes y equals 2x plus c, right? So you have put the value of m there, which is 2. And now the question is, how do you find the value of c? This is a point that we know lies on the line. And what did we discuss before? Any point that lies on the line must satisfy the equation of the line. Okay, so if -2 and 5, this point lies on the line, that means it must satisfy this equation. That means if I were to input that point in this line, the left-hand side and the right-hand side, they will be equal to each other. So what I can do is I can put that point here. I can say, let's input -2 and 5 inside this. That means in place of x, you put 2. In place of y, you put 5. And see what that gives you. That gives you 5 equal to 2 into -2 plus c. Now simplify everything. 5 equals -4 plus c, and the value of c turns out to be +9. So your equation becomes y equals 2x plus 9. That's the equation of the straight line that we were looking for. So if you do not have the y-intercept given directly, and you just have the gradient given and any one random point given, what do you do in that case? You use the value of the gradient and the point that you're given to find the value of c first of all, and then you can write down the equation. Okay, that's another possibility. Now, it could also be that they don't give you the gradient as well. Okay, so in this case, the gradient was given, but instead of the y-intercept, we were given any other random point. Now, let's say we do not have the gradient given as well, and instead they say, find the equation of a line that passes through a point that is 1 and 6, and another point which is -2 and 1. Okay, so we have an equation that passes through these two. We have a line that passes through these two points. We want to find the equation of this line. How do you find the equation of this line? What's the standard form of the equation of a line? It's y equals mx plus c, right? That is the standard form of the equation of a line. Now, what do we need for writing down this equation? We need the gradient and we need the y-intercept, and we don't have any of those two things. Now, first of all, we start by finding the gradient. How do you find the gradient? y2 minus y1 over x2 minus x1. You can call any one of these points x1, y1, and then the other one would be x2, y2. What's the gradient going to be? y2 minus y1, so you can say that's 1 minus 6 divided by x2 minus x1, so that's -2 minus 1. And that becomes -5 divided by -3, and the gradient turns out to be 5 over 3. That's the gradient that we were looking for. Now we have the gradient of the line, so the line becomes y equals 5 over 3 times x plus c. Okay, so we put the gradient in the equation of that line, and this is what we get from that. Y equals 5 over 3x plus 5 plus c. So we found the value of m. Now, what about c? How do you find the point c? Again, you've got 2 points, 1, 6, and -2, 1. Both of these are points that lie on the line. Now, what do we know about points that lie on a line? They must satisfy the equation of the line. So we can input any one of those points in this equation. It doesn't matter which one. We can input this or this because both must satisfy the equation. And that will give us the point C. Okay, so what we have to do is just put one of these points here, let's say 1 and 6, and see what we get from that. 6 equals 5 over 3 times 1 plus c. Take 5 over 3 to the other side, and that gives us 6 minus 5 over 3. Simplify this. If it's in non-calculator paper, you can take LCM and simplify it. If it's in the calculator paper, you can put this directly on your calculator and get the result. If I were to do that, 6 minus 5 over 3, that is going to give me 13 over 3. So the value of c, therefore, is 13 over 3. Now that we've got the value of c, we can write down the final equation, which becomes y equals 5 over 3x plus 13 over 3. And that is the equation that we were looking for. All right. So that is how we can write down equation of a line. So if we have the y-intercept already given and the gradient also given, we can just input them directly. If we have gradient given along with one point, we can use that point to find the value of c. And if we don't have the gradient given as well, and instead of that, we have 2 points given, we can first find the gradient and then use any one of those 2 points to find the value of c, and then we can write down the equation. Now, this is one way to find equations of straight lines. using this form y equals mx plus c. Okay, and that will work in every single case. You can find equations of any lines using this standard form. However, we have another possible form that you can use as well, and that looks like this: y minus y1 equals m into x minus x1. This is another form for equation of a straight line. Just like we have y equals mx plus c, we also have y minus y1 equals m into x minus x1. Now, this also comes from y equals mx plus c, essentially. Uh, you can prove this, but we are not going to go into that right now. You can find that proof in one of my A-level videos on coordinate geometry. But we will need to remember this form. We will need to memorize this form as well if we want to use it. Although we can do everything without this as well, this will make things a lot simpler in some cases. So I really recommend that you understand this as well. How does this form work? In the previous form, we had y equals mx plus c. M meant the gradient, m stood for gradient, and c was the y-intercept, right? So if we had the gradient and the y-intercept, we could write down the equation of the line. Now in this form, we need two things. One is still the gradient, so we still need the gradient. M represents the gradient. So in order to use this form, you need the gradient. But now y1 and x1, they basically represent the coordinates of any point on the line. In the previous form, we needed c, which was the y-intercept in particular. But in this form, x1, y1 basically means any point on the line. That means the point that we have does not necessarily have to be the y-intercept anymore. If we have any point, we can write down the equation directly. Okay. Now, let's try to do this. Let's try to apply this on each of these examples that we did earlier using the other form and see how this other form, this second form, will work in each of these three different cases. Let's try that. So I'm using the same examples, but now we will do the same examples using this second form. And then I'll tell you when to use which one, when is one going to be more efficient than the other. But these were the three different examples that we looked at earlier. Now let's say we had to use the second form for finding equations of these lines. Now, one is we need to find the equation of a line that has gradient -2 and a y-intercept of 3. Okay, now what does this form tell us? Y minus y1 equals m into x minus x1. Now, do we have the gradient? Yes, we have the gradient that is -2. Now, what about x1 and y1? If the y-intercept is 3, what does that mean? What's the point that we're talking about? Y-intercept is 3. Think about it. If this is y-axis, this is x-axis, y-intercept being 3 means there's a point here. This is 3. What are the coordinates of this point? They will be 0, 3, right? The x-coordinate will be 0, and the y-coordinate will be 3. So the point that we essentially have is 0, 3. The x-coordinate is 0, and the y-coordinate of that point is 3. Okay, we can input that point here in place of x1 and y1, so that it becomes y minus 3 equals -2 into x minus 0, y minus 3 equals -2x, and y equals -2x plus 3. And that's the equation of the line that we were looking for. We got the same thing here as well. But in the previous case, for this example, y equals mx plus c was more efficient because we had the y-intercept already given. So we could just write down the equation directly using the y equals mx plus c form. In this case, we had to show a few more steps. although we got the same result, but it was not as efficient. However, for the other two examples, the second form is going to be more efficient now because we would not have to find the value of c in this case. Let's consider this example. Find the equation of a line that has gradient 4 and passes through -2 and 5. Now, what's the standard form that we have? Y minus y1 equals m into x minus x1, right? That's the form that we have. Do we have a point that lies on the line? Yes, this is x1, y1. So a point on the line, we call that x1, y1. This is gradient, which is m. Now, in the previous case, using y equals mx plus c, we had to find the value of c in this case. Now, if we use this form, y minus y1 equals m into x minus x1, we don't have to do that anymore. We can directly input values in this. We can say this is y minus y1. So in place of y1, we can put 5 equals m, which is 4, into x minus x1. x1 is -2. Let's put that here. And that's what we wanted to do. In place of -2, we put, in place of x1, we put -2. In place of 5, we put, in place of y1, we put 5. And in place of gradient, we put 4. And we have this equation that we were looking for. We can simplify this and get the equation in standard form. Y minus 5 equals 4 into x plus 2. And that will give you y equals 4x plus 4 times 2, which is 8. And then 5 from the other side. That becomes y equals 4x plus 13. That's the equation of this line that we were looking for. Using y equals mx plus c. Okay, I'm sorry. Gradient was 4 in this case. Wow, okay. So in the previous example, I actually wrote 4 there as the gradient, but I used 2 here in the equation. Okay, I'm sorry about that. Let me just correct that as well. This should have been 4 here, and this should have been 4 here. And then this would actually become 4 times -2, which is -8, and c would have been 13 here. And the final equation would have been 4x plus 13. Okay, so when I copied 4 from here, I by mistake wrote 2 there. So that was 4x plus 13. And using this other form as well, we are getting 4x plus 13. Okay, so we're getting 4x plus 13 from both the forms, but this is quicker now because we don't have to find the value of c anymore. We can write down the equation directly like this. Okay, let's do another example using this second form. Now we had to find the equation of this line that passes through 1, 6 and -2, 1. Again, how can we do that? Y minus y1 equals m into x minus x1. What about m, the gradient? In this case, we don't have that. Gradient is still required. So the first thing we have to do is we have to find the gradient. Let's find that. y2 minus y1 over x2 minus x1. Again, we can call any one of these points x1 and y1, and then the other one would be x2, y2. y2 minus y1, that becomes 1 minus 6 divided by x2 minus x1, which is -2 minus 1. And that simplifies to -5 over -3, which is 5 over 3. That's the gradient of the line. Now, once we have the gradient, we can input that here in place of m. We can say m is 5 over 3. And then in place of x1, y1, we can input any one of the 2 points that we have. We can either put these two coordinates, or we can put these 2 coordinates. Both of them are going to work. Okay, any of them can be used. Let's use these 1, 6 and see what we get from that. So in place of x1, we can put 1. In place of y1, we can put 6. And let's simplify everything. That gives us y minus 6 equal to m, which is 5 over 3, times x minus x1, which is x minus 1. Let's simplify this. This becomes y minus 6 equals 5 over 3x minus 5 over 3. 6 goes to the other side, gets added there, and we have y equals 5 over 3x plus 6 minus 5 over 3, which will simplify to 13 over 3 as we saw earlier. And that's the equation of the line that we were looking for. Again, that's less working than what we had to do here when we used y equals mx plus c. Okay. So how do we know now which form to use in which cases? We have two forms. One is y equals mx plus c, and the other is y minus y1 equals m into x minus x1. That we have discussed. Number one, y equals mx plus c, and number two, y minus y1 equals m into x minus x1. I would recommend that you remember both of these forms. Each of them can be used in every case. So you can find all equations of lines using the first form, and you can find all equations of lines using the second form. Both of them will work in every single case. However, the first one is going to be more efficient when the y-intercept is already known. You already know the y-intercept. In that case, when you know the y-intercept, that means you know the value of c already. Using this first form is going to be much quicker. And that was the first example that we did here. In this example, when the y-intercept was known, using y equals mx plus c was much quicker. It gave us the result in a single line. However, when the y-intercept is not given, in that case, using this second form will be more efficient. So this is what we use when the y-intercept is not given. Because in those cases, the second form is going to be more efficient, as we would not have to find the value of c here, and that will reduce our working. Okay, so the takeaway is that you remember each of these two forms, use the first one when the y-intercept is given, and use the second form when the y-intercept is not given. Okay, so that's how we find equations of lines. What do these equations of lines represent? They represent every single point on this graph that we've got. Every point on the line should satisfy the equation of the line. Okay, you need to keep that in mind. All right, now sometimes what happens is you have the equation of a line given, and you have to find the gradient of the line using that. So let's talk about this small concept before we end today. Finding gradient of a line from its equation. Finding gradient of a line from its equation. Now, sometimes you would have some equation given, and you would have to find the gradient of some gradient of that line from that equation. For instance, let's take some examples. Let's say we have a line that looks like this: y equals minus 5x plus 9. What we want to do is we want to write down the gradient of this line. What's the gradient of this line? How do you figure that out? You compare with the standard form. What's the standard form? The standard form is y equals mx plus c. You compare with that. What do you have as the coefficient of x? The coefficient of x in this case is minus 5. So you say the gradient, therefore, is going to be minus 5. Okay, so if you have the equation given in this form, you can say the gradient is negative 5. All right. Okay, let's take another example. Let's say we had something like this. 5y equals 10x minus 7. What if we have an equation like this now? What's the gradient of this line? Now, before we can write down the gradient of this line, we would first need to convert it to standard form. What's the standard form? Y equals mx plus c. So first of all, convert it to that form such that you have y as the subject. We should not have any number multiplying with that. It should just be y. Okay, so let's convert it to standard form. How do you do that? You divide the whole equation by 5. So divide 5 on the other side, and that will give you 10 over 5 times x minus 7 over 5. And that simplifies to y equals 2x minus 7 over 5. And now you can compare it with the standard form, y equals mx plus c. What's the coefficient of x that you've got here? It's 2. So you say the gradient of this line is equal to 2. Okay, don't write the gradient directly by looking at this number here. It's not 10. The gradient is supposed to be 2. Okay, but after you convert it to standard form, it turns out to be 2 like this. Okay, let's try down another example. Let's say you've got something like this instead. 3x plus 4y, or it's actually it's minus 4y equal to 12. Okay, what about this now? What about the gradient of this particular line? 3x minus 4y equals 12. Now, again, we cannot write down the gradient directly. We should first convert it to the standard form. What's the standard form? You can make y the subject. Okay, let's try doing that. This is negative y value right now. One way to approach this could be that you take this term to the other side. Right? That's one way of thinking about this. Or you can take 3x to the other side as well. It's your choice. It doesn't really matter. If we take 3x to the other side, that will make it minus 4y equal to minus 3x plus 12. Okay, so I've taken 3x to the other side. Now, is this the standard form? It's not. We do not want any number multiplying with y on the left side. So what do we do now? We divide by negative 4 on the other side. And that will give us y equal to minus 3 over minus 4 times x plus 12 over minus 4. And that simplifies to y equals 3 over 4 times x minus 3. And now from this form, we can write down the gradient. We can say the gradient is supposed to be y equals mx plus c. And the coefficient of x here is 3 over 4. Therefore, the gradient equals 3 over 4. And that is what we were looking for. Okay. So given the equation of a line, if you want to find the gradient of that line, you first of all convert it to standard form. And once you've done that, you look at the coefficient of x. The coefficient of x will be the gradient of that line. All right, I hope that makes sense. This is how we find equations of lines. Now, in the next class, we will talk about how to find equations of perpendicular bisector. That is one thing that we're left with, and also how to use a vector method to find some missing points. Sometimes we'll talk about that second thing as well. These are two things that we need to talk about. And also, when you have lines connected with inequalities, so linear inequalities, when you have to shade the diagram based on some linear inequality. We'll talk about that in the next class as well. But this is it for today. If you have any quick questions, let me know. Otherwise, we end this class here. No problems. Okay, good. So we will continue from here in the next class. There are just a couple of things that we still need to do in coordinate geometry, and then we'll connect it to the shading inequality questions that we sometimes get, which are related to equations of lines as well. But that's for the next class. This is it for today. I'll see you again tomorrow, inshallah, in our next class. Allah Hafiz.